Welcome to The Explainer, where we break down complex tech topics. Today, we're diving deep into a piece of technology that is absolutely essential for almost every large-scale website you use: distributed caching. All right, let's just start with this quote because it perfectly sets the stage. It tells you exactly why this stuff matters so much. In the world of massive online services, speed isn't just a nice-to-have feature. It's directly connected to the bottom line. Every millisecond, literally every tick of the clock, can mean millions of dollars.
So let's rewind. Every application starts somewhere, right? And usually it starts simple. Picture one server doing everything. It runs the app code, it talks to users, and it holds the database. For your first few customers, this is perfect. It's simple, it's clean, and it just works.
But then, a good thing happens. You get popular. More users mean more traffic, and that one little server starts to sweat. The first, most logical move is to give the database its own home. You split it off onto a dedicated server, letting it focus on one thing: managing your data.
And here's where it gets interesting, because when you solve one problem, you usually uncover the next one. With thousands of people now using your app, most of them are just looking at stuff, reading profiles, scrolling feeds, browsing products. All those read requests start to hammer your brand new database, and suddenly it becomes the bottleneck. The whole system starts to feel sluggish.
So this brings us to the million-dollar question that every scaling system has to face. How in the world do we deliver the data people want, like instantly, without our database just falling over from exhaustion?
And the answer, my friends, is a cache. The key idea here is that a cache is a layer of super fast in-memory storage. And because reading from RAM is just orders of magnitude faster than reading from a database that lives on a disk, a cache can serve up popular data in a fraction of the time.
I absolutely love this analogy. It makes the whole concept just click. The first time you ask for something complicated, the barista, that's your database, has to do all the work. But the cache is like that friendly cashier who remembers your usual order. The next time you walk in, it's ready almost before you've finished asking.
So what we do is we slide a new cache tier right between our application and our database. And here's the critical part. For a big application, this can't just be one machine. That would create a single point of failure and a new bottleneck. Instead, it needs to be a distributed system, a whole team of servers working together, acting as a high-speed protective shield for our database.
So how does this work in practice? Well, most systems use a pattern called cache aside. It goes like this. When your app needs data, it first asks the cache, "Hey, do you have this?" If the cache says yes, that's a cache hit. Amazing, we're done, it's super fast. But if the cache says no, a cache miss, then the app has to take the slow road to the database, grab the data, and, this is key, it puts a copy of that data into the cache on its way back to the user. That way, it's ready for the next person who asks.
Okay, so when you start talking about distributed caching in the real world, you're going to hear two names pop up constantly: Redis and Memcached. These are the giants, the absolute titans of the field. They're both open source, in-memory data stores that are built for one thing above all else: speed.
This table really nails their different philosophies. You can think of Memcached as a purebred race car. It does one thing, caching simple bits of data, and it does it with blinding speed. That's its purpose. Redis, on the other hand, is more like a Swiss Army knife. It supports all these complex data types, which means you can use it for way more than just caching. You can build entire features on it, like real-time leaderboards, messaging systems, you name it.
So you're probably thinking, great, caching is the answer to everything. But, in system design, there's no such thing as a free lunch. Adding a powerful distributed cache is a game changer, for sure, but it also introduces a whole new layer of complexity, and with that complexity comes a whole new set of ways things can go wrong. First up, you've got this wonderfully named problem, the thundering herd. Imagine thousands of your most popular cached items all have the same expiration time. The second that time hits, they all disappear from the cache at once. Suddenly, a massive, synchronized stampede of requests blows past the cache and slams right into your database. To avoid this, engineers will often add a little bit of randomness or jitter to the expiration times.
Next up is cache penetration. Now, this one can be pretty sneaky, and sometimes it's even used maliciously. An attacker could repeatedly request data for an item that they know doesn't exist. So every single request misses the cache, goes to the database, finds nothing, and comes back empty-handed. This can slowly bleed your database of resources.
A common fix is to actually cache a "we don't have this" response for a short time.
Cache breakdown is kind of like a laser-focused version of the thundering herd. It's not about thousands of different items expiring, it's about just one. But it's the most popular item on your entire site, the hotkey. The moment it expires, thousands of users try to get it at the exact same instant. The solution here usually involves some kind of lock, so only the very first request gets to go to the database and refresh the data for everyone else.
And finally, we have the nightmare scenario. The cache itself crashes. The entire system goes down. Your protective shield is just gone. And now, the full, unfiltered fire hose of all your application's traffic is aimed directly at your database, which will probably cause it to fail too. This is exactly why high availability and redundancy are absolutely critical when you're designing a cache tier.
But even with all those scary failure modes, let's be crystal clear. For large-scale systems, caching isn't just a nice-to-have, it is essential. It is the single most powerful tool you have for slashing latency, for protecting your database, for jacking up your system's throughput, and for ultimately keeping your application available and feeling fast for your users.
And that really brings us to the biggest takeaway here. Caching isn't just a technology, it's a strategic trade-off. You are consciously deciding to trade simplicity for raw performance. You get incredible speed, you get massive scale, but the price you pay is a more complex system with new and interesting ways to fail. And that is the true art of system design. It's not just about finding the fastest solution. It's about understanding the trade-offs you're making and being smart about how you manage the complexity that comes along for the ride.